In question 2, we have electrons with a range of kinetic energies hitting atoms which are in their ground state. This leads to photons with various frequencies being emitted. In part A, we're asked to explain what is meant by the term ground state and to describe the process taking place. Well, the ground state of an atom is when the electrons are in the lowest energy level. Electrons can only occupy particular energy levels, and when one of the passing electrons collides with an electron in the atom, it can raise it up to one of these higher energy levels. The electrons will soon return to a lower energy level. In doing so, they emit a photon with energy equal to the difference between their initial and final energy levels. In B part 1, next we have a table showing the kinetic energy before and after the collision of two electrons. The first electron has 5.5 electron volts before and after the collision. The second electron goes from 9 to 1 electron volt during the collision. In part 1, we need to explain this difference. Well, the first electron has insufficient energy to raise an electron in the atom to a higher energy level, whereas the second electron gives some of its energy to raise an electron in the atom to a higher energy level. In part 2, we're asked to convert 9 electron volts into joules. Well, to convert from electron volts to joules, we multiply by the charge on the electron, 1.6 times 10 to the minus 19, giving 1.44 times 10 to the minus 18 joules. In part 3, we're asked to calculate the maximum frequency of the photon emitted when the 9 electron volt electron collides with an atom. Well, photon energy E is equal to the Planck constant h multiplied by the frequency, which we can rearrange as frequency is photon energy over the Planck constant. The photon energy in this case, well, the electron has gone from 9 to 1 electron volt, so it has lost 8 electron volts of energy. To convert this into joules, multiplied by the charge on the electron, divided by the Planck constant. This gives a frequency of 1.9 times 10 to the 15 Hertz.